Symmetry is when we can take a shape and literally fold it in half and have the halves match up. Or we can also have it spin around a point and have it match up again. So today we will be talking about two different forms of symmetry, line symmetry and rotational symmetry. So just to let you know what line symmetry is, if we took a shape and folded it in half, so I'm going to take this sheet of paper, okay? I can fold this sheet of paper in half and the two halves match up. So I can also fold the same paper this way and have it match up. So we call the lines that we can fold lines of symmetry. So we have line symmetry when we can literally fold or reflect across that line and have it match up. And a shape can have multiple lines of symmetry. Now we can also have a shape. I'm going to take the same sheet of paper, and I'm wondering if I took a diagonal line, will it match up? Well, let's fold it and see. You see how they do not match up even though I folded it diagonally along this shape. So we have to be careful that we don't accidentally put in a line of symmetry where it doesn't exist. So this rectangle shape has two lines of symmetry. It does not have a diagonal one. So let's look at some other shapes. I have an isosceles triangle here. I can put a line of symmetry right here that the two shapes, if you imagine it being folded on top of each other, they will match. Now I can do it through here because here are my two congruent sides. If I try to do another one, say here, that's not going to match up. So this is not a line of symmetry, this is. Now if we have a square, and we know that a square has four congruent sides and four congruent right angles. So we could have a line of symmetry here. We could have a line of symmetry there. But unlike our rectangle, if we reflected it over a diagonal line of symmetry, we would still have it being line symmetrical across those diagonals. Now let's look at a rhombus. So it's kind of like a square, except we don't necessarily have the 90-degree angle. So we could have a diagonal. We know that here are two congruent sides of this triangle, two congruent sides of this triangle. It'll fold up on top of each other. Here's another line of symmetry. But if we tried to put one here and fold it, it's not going to match up because this point is sticking out, for lack of better word, and when we fold it down, it's going to end up down here. So we just have to make sure the shape that we have, and if we're talking about the appropriate lines of symmetry. Now there's another form of symmetry, and that is when you take a shape and you pick a point in the center, and if you can rotate it around itself, it'll line up. It'll be rotational symmetrical. So I will use this shape right here. So it's a circle, and then I put a point in the center and I drew three lines, and those actually form 120-degree angles. So I cannot form line symmetry. If I could fold it like this. I could fold it in other ways and it would match up. I can also spin it and it will line up along itself if you look at those straight line segments. Okay, so there would be another, and I'm going to spin it again, same direction, and it will line up with itself. Okay, so this is what we call rotational symmetry. So those are your two forms of symmetry.